Okay, so welcome everybody to this Edge Impulse and Synaptics webinar, Design of ML Models for Katana. This will be presented by Ananda Roy from Synaptics and Omar from Edge Impulse. During the webinar, you have the opportunity to ask questions. If you could put those in the Q&A box, then we'll get through those as we can and share those answers with you. And with that, I'll pass over to Ananda.
Hi, everyone. Thanks for being here. So I'm going to today talk about our Katana SoC, the different kinds of products that you can build with it, and why the partnership with Edge Impulse is so important to us. And then I'll hand it over to Omar, who's going to show you how to build AI models for the Katana SoC. So before we dig into Katana, let's take a step back and see why it is important and what we are addressing with it. So when people have been talking about computer vision until now and AI, typically people think of like taking high resolution, high frame rate images, sending it to the cloud, and a lot of the AI processing happens on the cloud. But that's typically quite inefficient for both in terms of data transfer, data bandwidth, and also power consumption. Because the more you do this transmits and receives, you run out of battery, and if you're running battery-powered cameras and other such devices, you'll run out of battery very soon. So there are a class of computer vision problems that lead to applications which you can run on constrained devices such as Katana. Things like object and people detection, image classification, tracking, and pose estimation, and which lead to different kinds of applications such as people detection and counting, fall detection, optical character recognition such as reading of digital meters, QR codes, barcodes, and so on. You can do it at the edge at very constrained compute in milliwatts of power level requiring very little memory. So let's see what is inside this Katana SoC. So the Katana SoC is a very capable SoC. So you have like 6 cores in it, 2 of them standard cores, one being an ARM M33 core, which can be used to write different kinds of application software, and the user can write their own code into that. And then we also have a standard Hi-Fi 310 Silica DSP core from Cadence, where you can run a lot of other DSP algorithms of your own. And then we have 4 other cores which club up to what we call the low-power neural processing unit, where basically all the AI and machine learning models run. And then it being an SoC, it has on-chip memory, it has a wide variety of digital interfaces that let you connect to other kinds of devices, such as cameras, microphones, or different kind of physical sensors, such as temperature sensors, pressure sensors, and whatnot. And then you can also interface it with the connectivity solutions, be it from Synaptics or any other vendor. So this is a capable SoC by itself that can also run AI models at very limited power levels. So what is the key value proposition? So we are the only SoC in the TinyML class which can do both vision and audio and other kind of sensing, yet maintain low power, very low power. So as you can see on my slide, we consume about a milliwatt for every megahertz, and the clock rates we can run the chip on is configurable all the way down to like 20 megahertz and up to like 100 megahertz. And in idle, when we are not doing any inferencing, we consume less than 800 microwatts of power. And then when you are turned off, the deeps or like in deep sleep mode, you consume less than 100 microwatts. And then we also, because Synaptics has this wide product portfolio, it leads, and also Katana being an SoC, you can basically build a full system just with a single chip solution and interfacing with other connectivity solution. So while a lot of our competition has either 1 or 2 of these, but they don't have all 3 clubbed into one. So you might have some of our competition who have built very capable NPUs, but then to build a full system, you need to buy a standard MCU from one of the big MCU vendors. Or like these big MCU vendors, they run a lot of their machine learning models in their MCU cores, but then because they don't have dedicated hardware and neural network accelerators on chip, you consume a lot of power. So we basically let you build low power computer vision and audio applications and allow for full system build-up, being a one-stop shop. So let's look at a few of the market segments and applications that Katana can go into. So let's start with the smart building space, where you can do things like people counting, space utilization, and compliance. For example, in a big office building, you might want to see which conference rooms are more used than others, so that when you need to expand, you can like change your unused conference rooms into cubicles. Or if you have a vision sensor on each of your floor, it counts how many people go in and out, and that gives you an idea of how many people are on a floor, and that way you can design smarter HVAC systems, like increasing or decreasing the heating and cooling accordingly, which would basically make your buildings more energy efficient. We are very focused on another segment called ambient assisted living, which is a very strong emerging market. As life expectancy increases, the people above 65, that population and demographic is also increasing, and also they're choosing to live by themselves as opposed to living in an assisted facility. What that does is it leads to a challenge where the near and dear ones living in other parts of the world or other parts of the town uh, still need to know what is happening with them. So having a vision sensor which is non-intrusive and does not basically stream or store any image on the device or stream to the cloud, you can still monitor whether someone's doing well, they have taken frequent visits to the kitchen or not, or if they have taken a fall, which is a bad thing to happen. You can build this kind of vision sensor devices which does not intrude on someone's privacy. We are strongly looking at the industrial applications as well, where you can do things like automatic digital meter reading, predictive maintenance, asset monitoring, and also sound and vision event detection, which can lead to show or indicate earlier as machines or systems are failing, so that they can be serviced well in advance before they actually fail. We are heavily engaged with a lot of security providers as well to build battery powered cameras, so that the false detects are minimized and actual humans are detected, and only when it's a qualified event, that event is streamed to the cloud, as opposed to, like, let's say a leaf moving in your backyard or the squirrel jumping, and which sends like enormous amounts of uh, garbage data to the phone or to the cloud, and that thereby draining the battery. And then we are also looking at various consumer electronics such as PCs, televisions, and whatnot, where it's important to know how many people are in front, how many people are watching, if someone is using a laptop or not, and then have an intelligent wake up when the person is actually sitting, or if they're going away, then it will shut down or lower dim the screen. So there's a lot of power efficient, energy efficient applications you can even do in the consumer electronic space. So why is this partnership with Edge Impulse important to us? So as we know, like our customers would be building products using Katana would be of a wide variety. Some might be extremely capable, have big machine learning teams who can just take our SDK and then build their own AI and ML models. But there would be a significant big class of customers who have very capable embedded engineers, but they might be new to machine learning or ramping up on machine learning. So we want to provide them a good tool where they can actually prototype and design machine learning models for vision and other kinds of sensing without having to write like tons of lines of code. Edge Impulse has a brilliant web-based software called Edge Impulse Studio, where you can basically design and prototype models choosing from drop-down menus and drag and drop. It's a very capable IDE, so as to say. And then what we provide is what you see on the right. What we are calling on chip is our SDK, which comes with an AI compiler and also the regular necessary sensor drivers, such as the camera drivers, microphone drivers, other kinds of sensor drivers, and also all the required firmware and middleware needed to run your binary onto the chip. So if you have a team of very capable engineers who need to develop machine learning models very quickly for Katana, please check out the Edge Impulse Studio. It's a very capable chip. And to enable product development and prototyping, we have this evaluation kit, which basically comes with the Katana, as you see, the red square on the left, which is basically our Katana SoC module, which comes with the Katana SoC flash and the power management chip on one module. And then we also have our Synaptics connectivity chip, which is a Wi-Fi Bluetooth combo chip on board. And then also on the baseboard, you have other kinds of sensors such as microphones, accelerometers, and the light sensor. And it also comes with a camera module from Himax, which basically enables the image gathering and image collection for this low power, low frame rate kind of applications. So this evaluation kit is already available to a lot of our alpha customers, and we are building a lot of them. Soon it will be available through our distribution channels, where you can go and order one or two or quite a few of these boards very easily, and it will be available to you for development using the Edge Impulse Studio. With that, I'm going to hand it over to Omar to talk more about the Edge Impulse Studio.
Thank you, Ananda, for the introduction and the nice presentation. I'm going to start by sharing my screen. Then let's go with the slide that I have. Very good. So, and yeah, as Ananda said, you know, in Edge Impulse Studio, we provide you with machine learning framework that you can use in order to build and design and prototype machine learning models that you can, you know, take and download from the Edge Impulse Studio and use on the Synaptics Katana. So today what you are going to see is you're going to see in detail how you can collect datasets from the device, or if you have dataset that you have locally. Then you are going to design a machine learning model, and you are going to test this model to see how accurate the model is. And finally, we are going to deploy the model back to the Katana board. And also the most interesting part is to see how we can also capture images back from the Katana and then feed them back to the studio and improve the model over the time. Because the idea is to create some kind of iterative learning where at each step, we collect more data sets from the board, and then we improve the model over the time. Now we are going to see the collection step for the data set, where we provide you with several ways to add your data set. And the first one, you can have your data set in the cloud. So if you have your data set at, you know, Amazon Web Services, or in the cloud, Google Storage, or even locally at your own cloud, we can provide you with a very simple tool to have and mount your dataset inside the studio. If you have your dataset locally on your computer, you can just upload them to the studio. And finally, you can connect your device to the studio, the Katana board, and start capturing images from the device itself. We also provide you with the auto labeling tool. So, you know, if you are looking for object detection, you know, you can upload all the images that you have to the studio that are not labeled, and then use the model that you have trained already, or, you know, any one of the models that you provide, and use this model to label your data sets. And, you know, it's very simple process where you can label thousands of images, you know, in a couple of minutes. So once we have collected data sets, second step is we are going to design our machine learning model. So the first thing we see is, you know, we need to define what is the input to our model, which is, you know, on the for time series data, it's going to be this interface, but for image data, you can see the need to define the width and the height of the images. Also, we provide you a lot of, you know, processing blocks, which are basically digital signal processing algorithm. All of these algorithms are open source, and you can go and see them on GitHub. Also, then you need to define the machine learning block. So it's depending on your project. If you are doing classification, regression, or transfer learning model, you need to select the one that is for you. And also now at Edge Impulse, you have the possibility to bring your own model. So if you have built your model locally, if you have like specific model that does something specific and you have already trained it and you don't want to go all over the process of training, you can just package your model inside a Docker container and then push the container to the Edge Impulse Studio and use this model on the device. So once we have trained the model, the next step is we need to do testing. So testing is done on the testing dataset, which is part of the dataset. And, you know, we provide you with a way to be sure that the model has very high accuracy. We show you, you know, the F1 score, the accuracy, the loss, and you can see, you know, the confusion matrix. You can see that the samples also, you can explore all of these samples and see which one that is, with very high accuracy, which one that is not working, and why. You'll have like more insight when you are on Example Studio. Last step is, if you're happy with the model, you can just take the model and deploy it back to the device. And we have like two ways to deploy it to the Synaptics Katana board. The first one is by using the TensorFlow library. So if you have a C++ application that you are working on and you'd like to integrate, or you are building your own firmware, if you are integrating that, if you'd like to build that and add it to the device, you can integrate the TensorFlow library into your application, compile the entire application, and then deploy it to the device. Or we can provide you a fully working firmware, and you can just download it and use the firmware on the Katana board. So what you are going to see now is how we are going to do that. So how we are going to connect the Katana board to the studio. I'm going also to show you the studio in itself, how to use it, and how to play with it. So let's start with a live demo. And the first thing is, let's go. Let me see. Very good. So today we are going to see this project, which is called XAI, which basically we have images of eggs, and these images are we are trying to do a classification and try to detect with the Synaptics Katana if the eggs are either like intact, they are same egg, or it's cracked. So like there's the egg is not not in the shape. So the first thing today we are going to see is the title of the project. So you can like give a title, define a README to this project, and also you can see you have a sharing panel where your project can be either private or public. Second step is the summary. So you see like the amount of data set that you have collected, the number of items. The more items you have, the better, where you can have a better model that is trained and you'll have higher accuracy. And also you'll see the number of devices that are connected to the studio. You can add your colleagues also as well. And, like you can work with them on the same project. All of them have access to the project and they can modify and train the model. And also you have the project information. So each project has its own ID, where this ID is important, so you can use it, for debugging. This ID also can be used the API. So, you can define your project to the ID, because you can also change the title and the README. So the only point to the project is the ID of the project. Also, you need to define the target device, which in this case is Synaptics Katana. And, so this one is really important because we are going to make the model, the computation of the model. We are going to do like simulation about the consumption of the model, about the flash usage, the RAM usage, and the processing time, how much is going to take from the CPU. So all of these computation, like calculation, are done when you select your target device. Also, you have the labeling method, which is interesting one to take care of. So you have two here. The first one is the one label per data item, and this means that if you are doing image classification, each image will have one label. Also, you can do bounding boxes. This one is for object detection. So if you are doing object detection, you need to select the second one, and you can have multiple labels per image. So next step is the devices. So when you go to device, you can see the device. So we have like the Omar Katana device, and you can have the ID of the device, the type of the device, and the sensor that is detected, and when the last time you have seen the device connected to the studio. And also you have the data sources and the data acquisition. The data sources is really interesting one, because it allows you to connect like your cloud environment. So you have like Amazon Web Services. If you have a Google Cloud, so you can add them using the data sources. Or what you can do is you have also data acquisition. So if you have connected the all your images locally, so you can just upload the images when you click on this button, You click on it, and you select all the files. You can split the files between training and testing, and you can do the inferencing. So if I have the label that are part of the file name, I can infer it from the file name, or I can give them the label manually. So you have your data set is going to be, part of it is the training, the other part in the testing, and you can see the split. And if I have the device now, which is just close to me, I'm going to power the device. And if I'd like to connect the device to Edge Impulse, I need to go to my terminal, which is this one here, back. And I need to call the Edge Impulse daemon, which, it's part of the Edge Impulse CLI that you can install using npm package, which is part of the npm JavaScript. I need to install it. If we start this one, so the device is already now connected, and it's going to tell you that the device is connected to your project, and going to give you the link to your project, so you can go there and start sampling images. One thing here is when you start this one, it's going to ask you for your credentials. In my case, they are known, so because I use the daemon every day, so and they have already connected it to the project, so it's not going to ask me. But when you start, it's going to ask you for your username and password, if in the one that you use to log into Edge Impulse Studio. Other way, if you'd like to log in immediately without if you have the API key, which we provide at the dashboard, I'm going to show you that now. You can provide it as a parameter to the Edge Impulse daemon, so you can automate the entire process if you'd like. If you try to integrate the Edge Impulse daemon inside a Python script. So let me show you that. So now everything is connected. If I go back to the studio, I can see record the new data. I can see the device name. I can give it a label, and I can see the camera here. So I get also the camera feed. I don't know if you can see it or not. And then I can sample, and I can select the resolution and click on start sampling. So I was mentioning the API key. If you go to the dashboard and you go to keys, you need the API key. With this one, you copy the API key, and then you use it with the Edge Impulse daemon, and you can connect immediately to the Edge Impulse Studio without giving your credentials. So once I have all the data here, I can go all over these images, see them one by one. I can see the difference between the cracked eggs and the intact one. And if I am happy with the dataset, I can start to train a model. So I need to go to the Edge Impulse design. And the first thing I'm going to see is the input axis, which I need to define the width and the height of the images. So we do resizing for all the images you capture. If they are captured with the same, the correct width and height, then nothing is going to be done. But if you have taken the picture using your mobile phone, then we do resizing for all the images. Then we use our DSP block for the images, which if you have the images in color, then we change them to either we keep them in colors, or we can change them to grayscale if you'd like, or and also we do normalization for these images. After the DSP block, we do the ML block. So in this case, it should be either classification or transfer learning, because we are trying to classify the images. In transfer learning, we provide you with pre-trained models that we have at Studio. So you can get really good results with small amount of data set. Otherwise, if you don't want to use this transfer learning model and you have your own model, you can just click on bring your own model, and you can follow the tutorial there. Also, we provide different kinds of blocks. So also provide anomaly detection, transfer learning, for different kind of applications. But today we are looking into an image classification project. So this one are not going to be shown by default. Once you have set up the impulse, you need to click on Save Impulse. And then, you need to go on to Images. And here you can see each one of these, images is going to be resized. I'm going to put them in grayscale for the Katana board. And I can see the on-device performance for this DSP block, which is around, 40 milliseconds. And also you can get, the RAM consumption for this DSP block, which in this case is 4 kilobytes. Then I need to generate features. And then, I can see the feature explorer, where it's showing me the differences between, the intact images and the cracked one. And it's really interesting to see, the distances between these images, because when you click on generate features, we use UMAP algorithm to reduce the number of feature dimensions to 3 dimensions. And the idea here is to see the distances between these samples. And it's really interesting because you can give you some kind of idea about the complexity of the machine learning model that you need to build to be able to classify, like to separate perfectly between the cracked and the intact one. So if these, like distances are really close and these elements are really interconnected like the one another, then you need very complex model to separate them. But if you have like all the cracked points are here and the intact one are here, then you know that with very simple classifier, you can separate all of these. So this is also the on-device performance for the DSP. Once you have generated all features, I need to go to transfer learning. And from here, you need to define the number of training cycles, the learning rates, and the validation set size. Only these 3 parameters you need to define, but you can, go even more in depth and go to switch to Keras to the expert mode. And from there, you can change the Keras code if you are interested. But it's up to you, to follow, the one that is the most suitable for you. So the mobile, so the model that we use is the mobile net version 2 for the 96 by 96. There are different types of models that you can use. It's up to you. We provide all of these models, and also we have now efficient nets, for image classification and all of that. Also, these transfer learning models are for image classification. If you are looking for, object detection, then you will see different set of models here. So you click on Start Training, and once it's finished, you will get 2 models. The first one is a quantized model, an integer 8-bit, and the second one is an non-optimized one. You will see the accuracy, the loss, and the confusion matrix for the model. If you'd like to get really high accuracy, you need to add a lot of images. So, it's the way, you can like improve the accuracy of the model, or you can train more cycles. And, there are a lot of parameters that you can also change to improve the accuracy of your model. During the training process, you will see, the validation accuracy, how it's improving, how it's converging, and all of these standard Keras output that you will get during the training. So finally, you will see a very interesting thing. Also you need to select the target here for the Synaptics Katana. And the interesting part is these numbers. So now it's telling me that for this model will require around 1.6 seconds to do the inferencing on the Katana board, and is going to consume about 260 kilobyte of RAM and 160 kilobyte of flash usage. So these numbers are going to be different if you choose different model. So, but these numbers are for the Synaptics Katana board. So we have also live classification and model testing. So model testing will allow you to test the part of your data set, because we know that your data set has been split into training and testing. And in testing data set, now you can click on classify all and verify that the data set is this part of that, the model is behaving as it was trained to, because you need to this part of the data set has not been seen by the model. So now the model is seeing all of these images for the first time. So you can test the training of your model if it's well trained or not by click on classifying for these images. And what's going to happen is all of these images are going to have the same DSP step, and then they're going to be on the prediction using the transfer learning model that we have already trained. And then you get the accuracy of the model, number of images that are cracked and intact, and in this case it's 100%. All of them has been classified correctly. So we have also something called live classification, which the device is still connected. I'm not sure. Yeah, I lost the connection. So when your device is connected, you can capture images from the device and use the model that is on the studio to see if how it's going to perform on device. Because if you don't want to deploy each model you train, then you can just do live classification and capture the data from the device and see how it's going to perform. I lost the device. Let me see. Power it. Let's start pouring the device and see if I have it. Okay. Yep. Now everything is good. Yep, and you'll see you get the camera feed, and also you get the Katana and see the number of images. I have prepared, the 2 eggs here, and I would like to take an image. So if we can see here, don't know if I can show it to you. Yep, let's start with this one, where start sampling. Should be intact. Yeah, so this one is intact, this normal egg, and you can see from the image. Let's do another one. Let's go to the correct one. Hopefully that I have enough lighting. So this one is going to work. I'm not sure if this is a good image or not. Yeah, well, it's fine. It detected that it's cracked. So it's able, even if the image is not that good, with not good lighting, the model is behaving correctly. So the last step is, I see that the model is behaving correctly. I can go to the deployment of the model. And then from there, I have 2 options, as I mentioned in the slide. The first one is a library. So, I have the TensorFlow library. And here I just get a C++ code that I can integrate with my application, with my C++ application. And then, I can compile the entire application to get a binary that I can flash to the device. So the device here, the library here is providing you with, the model itself and the function calls that you need to use to do the inferencing from your application, so full functions, docs, and, you get the model embeddings inside the library. So you can select on this one, or you can build a firmware, where the firmware you need to select the Synaptics Katana, so it's the neural engine KA 10,000. And then either you select one of these, and then you need to click on. So I select the quantized model. You can also select the other one, but this one is better. It's smaller and with higher performance. And I click on build. So now we need to wait, for a couple of seconds. Let's say 20 seconds, 30 seconds, or even more to build the firmware. Because what we do is we take the library itself, we take our SDK, and we compile all of that in the clouds, and we build the firmware for you. And eventually, at the end, you will get the binary. And once the binary is ready, we provide you also with a video tutorial that is going to be seen at the studio. And from this video is going to guide you how you can flash the binary that we provided into the Katana board. So you get also the memory region and the consumption for this model, which is taking around 82% from the RAM, which is good, because you need to be sure that if you are building like a huge model, a very big one, it's not going to fit on the device. So you need to be sure that the model it fits to the device. So you can see on the memory region. If not, the studio is going to tell you that this model will not fit, and you need to reduce a couple of layers of your models in order to make it suitable for the Katana board. So now we need to wait a couple of seconds. So now it's finishing. Exactly. So you get zip file that contains everything, and you will get a video showing you, like, I don't know if you can see the video itself, but it's going to show how to get the zip and find inside it and the binary and the flashing script that are needed in order to flash it to the Katana board. So yeah, this one is around 1 minute, but if you'd like, sign up studio and build a model, and then you will get the model and flash it to the Katana board. So one last thing to show you is I've shown you the what is called the daemon, but also you can do the inferencing on the device. So you can do like run impulse, and you can start. So I need to point the Katana to the icon here, which is a bit far. But if you started, then it's going to take a picture, and it's going to do the prediction on the device. So now I'm not holding the device correctly, but yeah, if I hold it correctly, you'll be able to see that this one is cracked and the other one is intact. So either use live classification, but at the end, once you have deployed the model, you can use run inferencing to get once to get see like what's happening on the device. And this is once the model is running on the device, you start the run inferencing and you see the output of the model. Yep. So that's what it's for today on the studio. Last thing I wanted to show you today is if you'd like to start to the Katana board, please sign up on Impulse, create an account. From there, it's free to create an account. It's very simple, and we have a huge set of documentation to guide you how to start with the studio itself. And also we provide specific docs for the Katana board, where it's this one is going to show you how to use the Katana board, how to build models with specific tutorials. Also, if you'd like to get the Katana board, please use the following link that we have here. Thank you very much, everyone. If anyone have any questions, please let me know.
We do have some questions. I'm just also going to post in the chat the link to buy the board in case anybody would like to go ahead and purchase the Katana board. So a few questions that have come through. Firstly, how much memory is there on the Katana board? I guess that's for you, Ananda.
Great question, thanks. So yeah, the total on-chip memory is about 2 megabytes, out of which approximately 1 megabyte is system memory, which all the cores can access. And then we have tightly coupled, like the rest 1 megabyte is distributed and tightly coupled with each of the cores. And you can get that from our data sheet. Once you order the board, it comes with the data sheet as well. So that's what the answer is.
Okay, perfect. Next up, what frame rates can Katana support?
Again, another great question. So if you go to the Synaptics website, you'll see some demos like people detection and counting, meter reading, fall detection. So all those demos have been done at very low frame rates so that we can, again, draw as less power as possible. So those are at 24 megahertz clock and supports about 1 to 2 frames per second. However, as I said earlier in my presentation, the chip can run all the way up to 100 megahertz. So you can theoretically go up to 10, processing 10 frames per second.
Okay, and then I also have, can audio models also be developed for the Katana board?
Awesome question. Yes, so the Katana chip also supports audio, although our demos today were based on vision, but yeah, if you have audio data such as your voice recordings or like some kind of sound event, you can record them and then train using edge impulse to identify either people's voice or like some kind of local keywords without going to the cloud, such as help or start, stop, up and down, or even other different kinds of sound events such as glass breaking, gunshots for a lot of security applications that we are targeting, fire alarms, and so on.
Perfect. Thank you very much. I think that's it. All the other questions seem to have been answered during the presentation. So thank you everybody for coming on today. We will follow up with the slides afterwards. And this video also will be live on YouTube in the coming days if you want to re-watch any part of it. So again, thank you very much and we'll see you soon.